Okay, so this is section 9.2, arithmetic sequences and partial sums. So in section 1, we talked about just the idea of what is a sequence and a series and how you can express the next term, and we can do that with a formula, we can do it recursively, what are the different patterns maybe as we move from one term to the next. So in this section, we're going to focus in on the type of sequence that we call arithmetic. What does that mean? So it's a very special type of sequence. How you move from one term to the next is a very set definition. So we're going to talk about all of the ones that we consider arithmetic, being able to recognize them, find particular terms, be able to find the partial sums, and then to model those real life problems. So today we're going to focus in on this part 1, on this first bullet point here, being able to, how can I recognize, write, and find terms in arithmetic sequences? And then for part 2, we'll talk about the partial sums and the modeling. All right, so a couple things of note. What is an arithmetic sequence? So the differences between terms is constant. So there's a common difference. So the difference between terms is constant. And we'll say consecutive terms, just to make sure we're super clear on what we mean. All right, so you know what consecutive means, one after the other, right? So if you take any two terms that are right next to each other, one after the other, the difference between them is constant. They're always going up or down by the same amount. So we call that difference the common difference. It's what they have in common. Every difference is the same. So the difference between consecutive terms is what that common difference is. So it is that actual calculation. So it's the difference between consecutive terms. So anytime you look at a sequence and the difference between consecutive terms is constant all the way through, that would be considered what we call arithmetic. And the letter that we use to talk about the common difference is D. So if you start seeing people talking about the D value, it's the common difference. But that's very much the same though as when we talk about slope, when we talked about those equations. It's very much a linear situation. So when we're looking at these, we're going to think of them as like a linear equation, and the slope is equal to the common difference. So when we think about it, what we go up by each time or down by each time, that's our common difference. That's the D value. So that's the same as the slope. So when you think of these, think of them as linear rules or linear sequences. It really does help in your thinking. All right, so let's take a look at one and see if we can recognize if this is in fact arithmetic and what would that common difference be if it is. And then we'll see if we can use that kind of recursively here to find the next term. So taking the previous term to help find the next one. All right, so if we're going to check to see a common difference, what we do is we take any two terms and we find their difference. So 3 minus 7 would be a -4. -1 minus 3 would be a -4. -5 minus a -1, careful on the arithmetic there, -4. And then -9 minus a -5, also -4. So what we notice, yep, there's a common difference of -4. So every time, each one, we're going down by 4. Make sure you check for all the terms. It can't just work for one or two. It has to work for all of them. So this is definitely arithmetic. We have a common difference. If you think of it as a linear equation, we have a negative slope. So we're decreasing, right? The terms are getting smaller. All right, so how would you find the next term in the sequence? Well, you just subtract 4 again. So the next terms in the sequence, we do -9 minus 4 more. That would put us at -13. Minus 4 more again would be -17. Minus 4 more, -21, and so on. So that would be kind of a recursive way to identify it. We'd be taking the an, the nth term, subtract 4 from it, and we get to the an plus 1 term. So it's kind of a nice way to find that pattern. Right, let's try another one, see if this is arithmetic. So we just want to practice identifying. How can I know if it's arithmetic? Well, I'm going to check and see if there's a common difference. So what is the difference between the first two terms? Well, we're going up by 3, but then we go up by 5, and then we go up by 7, and then we go up by 9. Definitely not arithmetic, so this would be no, because that common difference isn't there. The first differences are not equal, but I'm hoping some of you might recognize these numbers. 1, 4, 9, 16, 25. Those look pretty familiar, I hope. Perfect squares, like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Check the second differences. Up by 2, up by 2, up by 2. Oh, this one's quadratic, right? So this would be a quadratic rule. So if we think about the second differences being equal, we talked about this in section 1 too, being able to recognize different patterns. If the second differences are equal, it's quadratic. And maybe you could even figure out what the rule would be. N squared, whatever your term number is, squared. So this is definitely not arithmetic because there's no common difference in that first set of terms. So no common difference. for the first differences. The second differences are equal, though, that's what makes it quadratic. So being able to recognize. Now, once we knew it was quadratic, we could find the next terms, 36, 49, and so on. But we want to be able to identify this special type of sequence called arithmetic. All right, so now what we're going to do is we're going to, again, kind of practice what we did in section 1. If I give you, instead of the actual sequence of numbers, so the list, what if I tell you the rule or the equation or the expression that represents it? So I'm going to give you an nth term rule. So I'm going to give you that this nth term, or an, is equal to 3n minus 1. So the question is, how do we know, even from looking at the rule, that it's arithmetic? Well, take a look. This is that y equals mx plus b format. This is a linear equation. So as soon as you see a linear equation, we know that that means it's going to be arithmetic. So look for that. That's a really important idea to connect. Linear is arithmetic. They are the same kind of rule. So if I have a linear equation, a linear rule, I can find any terms I want by using the domain of that function. So what domain do they want me to use? Well, they want the first 4 terms. Okay, what does that mean? That means the domain values they want me to use for n would be 1, 2, 3, and 4 then. I'm putting in n equals 1, n equals 2, n equals 3, n equals 4. Now, we can do it kind of the long way here. So let's see if we can find term 1. I'd be doing 3 times 1 minus 1. So 3 times 1 minus 1, that would be 2. And then I can find term 2. So 3 times 2 minus 1, so 6 minus 1 would be 5. Term 3, so 3 times 3 minus 1, which would be 7. And then I could find term 4, so 3 times 4 minus 1, which would be, let's see, well, that doesn't look right. 8, sorry, I can do arithmetic. So 8 and then 11, there we go. All right, so our terms in the sequence, they wanted the first 4 would be 2, 5, 8, and 11, etc., etc., right? They only wanted the first 4. Now, what a lot of people realize, though, pretty quick in the game here, if it's linear and you know what your common difference is, or your slope, so in this case, the slope of that linear equation is 3, remember that's the same thing as the common difference. Once people calculate this first number, then to get to the next number, instead of having to go back and doing all the arithmetic, how about just add 3 to it then? So I could just add 3 to get to the next term, add 3 to get to the next term, add 3. Might be a faster way of thinking of it, so you don't have to go back and do all the arithmetic. Both ways are fine, though, so we can identify arithmetic by linear equations as well, and we can generate the terms. So lots of different ways we can get that information. All right, let's talk about particular terms then in a sequence. So we want to be able to see, not just find the next ones, but is there a way that I would be able to find, say, like the 25th term or the 100th term? Like, I don't really want to write out all of them, like the whole list. And what if I don't have the equation? What if I don't know the nth term? Is there a way that I could generate or derive that formula, come up with what that value is? So that's what we're going to try. We're going to see if we can derive that formula using the sequence that we have right here. So we have a 1, 3, a 5, and a 7. So we're going to see if we can come up with, how would we come to an nth term formula if we have that. So I'm just going to use this sequence to help me come up with what these values are. So our term 1 is that, term 2, term 3, and term 4. The common difference, what are we going up by each time? Well, each time it looks like we're adding 2, so our common difference is 2. So let's talk about how we would actually calculate these. So we'll do a little bit background of information. So how do we get an A1 in a sequence? Well, it's just whatever the starting value is. So it's just going to be whatever A1 is, and I don't need any common differences. So a lot of times I would even probably write that, but just for the sake of argument here, I don't need to add anything on because I haven't moved yet, right? I'm at the first term. Okay, how are you going to figure out A2? Well, I'm going to take whatever the first term is, right? So 1, and I'm going to add, so I'll do kind of the arithmetic off to the side here. So I'm going to take whatever my first term is, 1, and I'm going to add 2 to it, my common difference. Okay, so I only add the common difference 1 time. So if I think about what I'm going to be doing there, I'm going to be doing 1 of those common differences, which would give me my answer of 3. We're going to see if we can come up with what the pattern is here. So how would you find the third term? Well, I know a lot of people would say, well, I'll just take whatever the second term is, right? And I'm going to add 2 again. Or think about it going back to term 1 again. What would you do from there? Well, I'd have to add the common difference again. So I'd have to add 2 2's, or I'd have to add 2 twice, if you want to think of it that way. That would get you to 5. And then how would I find the fourth term? Well, I'd start with that first term again. I know you could just go from term 3, but we're going back to the beginning so we can come up with that nth term. I could go back to the 1 and I could add, how many 2's would I need? Well, I would need to get to that 7. I'd need 3 of them. So I would need 3 of those common differences. So 6 plus 1, there's my 7. All right, so if I go back, I'm going to go ahead and write in my original one here. So I have just what my original term is, plus no 2's, right? So we'll go back and we'll write it the same way we did all the other ones. That's how I get my term of 1. Let's see if we can come up with what the pattern is. So I'm always going back to that term 1. So it looks like to get a term 1, I need an A1 plus no differences. We kind of talked about that already. How did we get an A2? Well, I did an A1 plus 1 of those differences. To get an A3, I went back to A1 still, my 1, but then I did 2 differences. So 2 2's, right? To get to the third term, I'd have to add 2 twice. And then to get to term 4, I went back to A1 and I added 3 differences. Now I want you to see if you can come up with a pattern here, what the rule is. So if I'm at term 1, I needed no differences. Term 2, I needed 1. Term 3, I needed 2. And term 4, I needed 3. So the number of differences is always 1 less than whatever your term number is. So what if it was AN? This is what I want to try to figure out. Well, it looks like all of these start with an A1, and I have some amount of common differences. How many common differences do you need? Well, it's always 1 less. So how do you say 1 less than N? It would be N minus 1. So to be able to actually get that nth term, all we need is the first term, and then we need 1 less of the common differences. You never need a difference for the first term because you have it already. You're just trying to figure out, okay, what would my number of differences be then? Well, I'm going to do that 1 less than the number of times I have to do. So think about it. What if you're going to find the 100th term? Well, then I would need 99 common differences. So I would do my A1 plus 99 of those D's. It's always going to be 1 less. So we can really quickly get to any place in the sequence I need to be without having to write all the terms in between. So this nth term formula we're going to be using a lot. A1 plus N minus 1 times D. Remember that D value is your slope, and the N minus 1 is your variable, and that A1 is your starting, or the term number, and then the A1 is your first term. So A1 is the beginning term in the sequence. So let's see how that could help us in a scenario. It says write a formula, so that means an equation for the nth term. So we're trying to write one of these for a sequence whose common difference is 2, so that's D equals 2, and whose first term is 7. So A1 is 7. They just want you to write the rule, the equation. So we can use our A1 plus N minus 1 times D, and we can write that equation. So for the nth term, it would be A1, which is 7. N is our variable, so that's going to be part of this rule. That's going to be to represent our domain values, and then times our common difference, which is 2. Now this is fine, it's what it is, but it might be easier to do a little bit of simplifying here, make this a little bit easier. So 2n minus 2, and then put together your like terms. Looks like it would be 2n plus 5, and we can get our nth term equation. So now I know, yep, this is a linear equation. It's definitely arithmetic. My common difference, or my slope, right, is the 2. So that's your D value, remember, as well. And then I can generate whatever terms I'd like. So I can find any term in the sequence I want. All right, well, I want to find the first 3 terms. So I could have gone back and just done that right away from the get-go here. If they gave me term 1 is 7, how would you find term 2 if you know it's arithmetic and the difference is 2? Well, just add 2, right? So I could have done the 9 and then 11, and I've got my first 3 terms. Great. Could I also now go back and use the formula and say, okay, what is, I guess I already know A1. What is A2? Well, it'd be 2 times 2 plus 5. There's your 9. And A3 would be 2 times 3 plus 5. We have kind of multiple avenues to get there. If I'm just writing the sequence, this is great. What if I asked you, though, instead of find the first 3 terms, what if I wanted term 70? Well, gosh, I do not want to go through and write out all the terms to get to term 70. I'm just going to do this 2 times 70 plus 5, and I can get right to what that term is. So I can actually figure out what that value is going to look like. So I think it's a way to just think of it in different ways, how we can get to that next term. So we can write the rule, so we can write that equation, but we can also just use that recursive where we can just add to get to the next term. All right, let's try that recursive then and see if we can figure out how that might work for us in that same fashion. So recursive, remember, is just the kind of formula that you use the previous term to find the next term. So they're talking about how can you find the n plus 1 term? Okay, what does that mean again? Well, if this is a n, the term that comes after it would be the n plus 1, right? One bigger. So if this is term 7, that would, this if an is term 7, that would be term 8. So how we get to the next one in an arithmetic sequence is you always just take whatever your term is and you add the difference, right? We've been doing that all day. So we can do that for any sequence as long as we know what the difference is. So they say, okay, we've got this arithmetic sequence that starts with a 15 and a 12. They want you to find the sixth term. So we want the sixth, or the a sub 6. Well, I guess we need to figure out what's our common difference. So let's take a look. So we have 12 minus 15. Looks like we're going down by 3 each time. So our common difference is -3. So if I want to find the next terms, here's some options. First way I can do this, I can just keep going. I can recursively, or just use the common difference, keep going down until I get to the sixth term. So I have term 1, 2, 3, 4, 5, and 6. So I keep subtracting 3 and I can get down to, oh, there's my sixth term. Looks like I'm at 0. Great strategy. That's called recursively, where you take the previous term to get to the next one. Could I also use the AN formula though? A1 plus n minus 1 times d? Sure thing. If I want to find the sixth term, I would do A1, which is 15, plus 6 minus 1, n is 6, remember we're finding the sixth term, times the common difference, which is -3. So we'd have 15 plus 5 -3s. So think about what that looks like here. So 15 plus 5 -3s, well, that'd be 15 plus -15. So we also get our 0. So think about what that formula did for you. Instead of having to subtract 3, 1, 2, 3, 4, 5 times, like separately to get to term 6, we subtracted 3 5 times all in one clump. That's the difference between recursion and then using the nth term formula. We can get right to that value. It's that repeated multiplication or the repeated addition there. We just did it all at once instead of in separate pieces. So you always have that option or that choice to be able to solve. So we just need to think about what's easiest. Now, term 6 wasn't so bad to do recursively, our method number 1. But gosh, if it was term 120, I might want to think about using the formula. It's a lot faster. All right, let's take a look at the last one. This is a great example to talk about. So what happens if we don't have consecutive terms? In all of the other examples, the terms were consecutive. So here's what your ultimate goal is. You want to find the 8th term of an arithmetic. So we know it's arithmetic. So your quest is for A8. Oh, no, sorry. The 8th term of the arithmetic sequence is 25. Gotcha. So they're giving us non-consecutive here. So the 8th term is 25, so A sub 8. The 12th term is 41, so A sub 12 is 41. Write the first 5 terms of the sequence. So really they want to have you find 1, 2, 3, 4, 5. Okay, well, here's what you know. Sometimes it's helpful to kind of visually write this out. So you have A8, which is 25. You do not have A9, you do not have A10, you do not have A11, but you have A12, which is 41. So in between the 2 terms you know, there are 3 terms that you don't have. All right, so let's think about what we really have. How would you work backwards to figure out what other terms are in this sequence? So let's think about what we really want. If I had a common difference, wouldn't it be great? Because then I could figure out any of the terms in between, but then I could also go back and figure out these. So think about, maybe pause the video for a second. How could you figure out how much these are going up by each time as we go from term 8 to 9, 9 to 10, 10 to 11, and then 11 to 12? See if you could figure out arithmetic-wise what you would do, and then we'll talk about it. All right, so here's what I would think. This is kind of like our starting term, and this is kind of like our ending term, and we have 1, 2, 3, 4, 5 terms in our sequence. So I know a lot of people just do arithmetic, but you can also use the formula and see if this matches your arithmetic, and we'll talk about the arithmetic too. What if we think of our nth term as the 41 and our first term as the 25? I know it's not term 1, but it's like a starting place. And then we have a total of 5 terms in our sequence. and I would be able to solve for the d. So take a look at the arithmetic I would do here. So 25 plus 4d equals 41. How would you solve that for d? Well, the first thing that you would do would be subtract 25. Think about what that means. 41 minus 25 is finding the difference between the top and the bottom number. Well, of course you have to do that. You have to figure out the total distance of change. So 41 minus 25 puts you at 16. And then what would you do next to solve? Well, you'd be dividing by 4. Okay, think about what the divide by 4 represents. Look back at our sequence. How many times would you have to add that common difference? Well, you'd be adding it 4 times. So in that entire distance I had to travel, which was 16, I want to divide that into 4 equal chunks. That means each chunk I'm going to be adding 4. Awesome. So I can do that arithmetic. So I bet what a lot of you were thinking is I'm going to do 41 minus 25. Yep. So that would be your 16, and then divide it by how many times you would add. So if there's 5 terms in the sequence, you would divide by 4 because you're only going to be adding that difference 4 times. Now that we know the difference, we can do anything. Okay, they want the first 5 terms in the sequence. So think about how you could do that. We could work backwards from term 8. So if it's adding 4 to go forward, so I could figure out what these numbers are in between, right? I don't really need them, but I could add 4 again, add 4 again, right? Add 4 again. If I can add 4 to go forward, I must be able to subtract 4 to go backwards. So I could subtract 4 and I could work forward in this sequence and I could find the first 5. That would be kind of like a recursive as well, finding the previous term. Or I bet we could do something like this to figure out what the first term is. We've got this equation. So what if we think about we're looking for A1? Don't we have some terms we could use as our AN? How about the term 25? That's the 8th term in the sequence. So 25 equals A1 plus n minus 1 times the common difference, which we now know is a 4. The only thing we have to figure out is the n. Well, if we're going to term 8, then that would be 8. And I could definitely use that to help me solve. In other words, figure out how many times you have to subtract 4 to get back down to that original 1. So think of it that way. So I have 7 common differences of 4. So that's a total of 28. And then how would you solve? Well, you'd subtract 28 on each side. So think about what that means. That means it's like you're subtracting this 4 7 times, right? So if I'm going to keep subtracting 4, subtracting 4, subtracting 4 to get all the way back to term 1, I'd have to do it 7 times, right? If I'm at term 8, same thing as subtracting 28 all at once. So where would that put us? Well, we'd be back down at -3. So the first term in this sequence is -3. Cool. So how do we get the next 4 terms? Well, we just start adding 4. We know our common difference. So it'd be -3. Then we'd be at 1. Add 4 again. We'd be at 5. Add 4 again. We'll be at 9. And then we'll add 4 again. And we'll be at 13. So we have term 1, 2, 3, 4, 5, and we can go on from there so we can connect those up. But they wanted the first 5 terms in the sequence. We've got those. So if you have non-consecutive terms, what we need to do is we need to figure out, hey, what's that common difference? So use the formula. It works great. So think about your relationship. Any term can be a starting term and any term can be an ending term. You just have to figure out how long is your sequence then when you do that. So that's great. Some people just do the arithmetic though. They think, okay, what's the total distance? How many common differences would I need? That's also great. So once you have that common difference, you can work forward and back however it makes sense. All right, so big picture today. What's an arithmetic sequence? Common differences are the same for those consecutive terms. So being able to identify if something's arithmetic, find terms in an arithmetic, and be able to write the rule.